Hey there, welcome to this lesson video. It's a quick intro to piecewise functions. Two things we're going to be looking at. We're going to be looking at evaluating piecewise functions and then also finding the domain and range of graphs of piecewise functions. So let's get started. So the first one, evaluating. Piecewise functions are kind of like two or more functions pieced together, and then in certain intervals you use a certain equation. And so our intervals, we need to be careful. For values that are smaller than -2, we're going to be using the first function. However, if our values are -2 or larger, we're using the second function. So the first question asked me to evaluate the value when x is 3. That's what this notation means. So then which function is it that I need to use? Well, I need to use the second one, okay, because x is greater than -2. So then I use the second one and I just plug in a 3 wherever I see an x. So I substitute x with a 3, and then I evaluate this. So this is going to be what? This is going to be 9 plus 6 plus 3. So that's 18. So that'd be my final answer for the first one. Now the second one, evaluate when x is -4. Which function do I need to use? Well, -4 is less than -2. So now I use the first function and I replace x with -4. So in other words, -4 plus 5 would be my value, which is 1. Okay? The third one, -2 is, well, it's equal to. So I have to be in the second equation. And again, I plug in -2 for x. Make sure, if you're going to use a calculator, since we're substituting in a negative value, definitely use parentheses on this one if you're typing it in. Okay? Because this is actually equates to a +4 plus a -4, which will cancel, and so my answer will simply be just 3. Okay, so that's just the basics of how to evaluate a piecewise function. Let's do this one. Number 3 here. I have 3 constraints this time. When I'm less than 0 or equal to, I use the first function. When I'm greater than 0 but less than or equal to 5, I'm in the middle. And if I'm strictly greater than 5, my value is simply just 3. So when I'm substituting in 0, meaning I have to be equal to 0, so I'm in the first equation, plug in a 0 into that first function. 0 minus 1 is just going to simply be -1. When x is 3, which constraint do I fall in? I fall into the middle constraint. I'm between 0 and 5. And so then I'm going to do 2 times 3 minus 1, which is 6 minus 1, which is simply 5. Alright. Maybe I'll go back and do the second one real quick. Why not? So I have 2 constraints, greater than or equal to 1 or strictly less than 1. So when I look at the first function, it wants me to plug in a -2. That's when I'm strictly less than 1. So I'm going to, again, use parentheses because we're substituting in a negative and we're squaring it. So we actually get a +4 plus 3, which is 7. And in the second one, I'm greater than 1. I'm 6. So that puts me into the first equation, and I'm plugging in a 6. So 2 times 6 plus 1, 12 plus 1 is 13. Okay, so there are my 2 values. Alright, that wasn't too bad. That went pretty quick. Now let's find the domain and range of a piecewise function graph. So clearly you can see, snippets of graphs, kind of just copy and pasted into one graph. So this is a piecewise function, and so we want to think about domain and range, and we're going to write it in interval notation because that's how we talked about it. And we're going to move, for the domain, we're moving left to right. So we've got to be careful. Remember, closed dots means the value is included. Open dots mean it's not. So we have a few things to talk about. So for this guy, for his domain, meaning left to right, we always start on the negative side. I have this line that it's understood to be, shooting out. I should have put the arrow there. So I'm coming from negative infinity. Okay, coming from the left. I don't know exactly where I start in the negatives. So I'm coming from negative infinity, and so then I'm trekking along, and then here I have this jump. So the x value of 0 is included because of this closed dot. So then once I get past 0, I'm on this graph. I'm still traveling left to right. And then once I hit x equals 3, it's included on this middle part, but anything past 3, I have to jump to this guy. So even though there were jumps, these closed dots kept everything moving, and there were no values that got jumped over. So we say this is negative to positive infinity for domain. Now the range, up and down, let's see what happens. I've got this arrow, so I'm coming up from the negative y values, and then I hit an open dot. Okay, so that means negative 2 isn't included. But then I gotta jump over here, because anything bigger than negative 2, I have an open dot here too. So here's where we have a hole. Anything less than negative 2 is in this graph. Anything greater than negative 2 for this segment is on this graph, but negative 2 on either part is excluded. So we have this hole. We have negative infinity to negative 2. We've got to jump over it. So remember, we talked about this, it's a union. And I use parentheses because I do not want to include negative 2. And so let's see where we end up after negative 2. If we have another hole, or if it just goes to infinity for us. So I've come up from the negatives. I realized I have a hole at negative 2. But as I move up this curve, I'm increasing my y values. Okay, here it seems like I have to jump, but the value of y is 1 is included in both segments, so I'm okay. And then I can keep trucking up the positive y values because this guy just keeps growing. So I just had the one hole to worry about at negative 2. So it's kind of complicated, but that's the domain for that, domain and range for this example. Here's another piecewise function. So let's see what happens here. Left to right. So coming from the negative x values, because of this arrow, I don't know exactly where I start, but I'm coming somewhere from that direction, and I'm moving to the right, and then whoop, I hit a hole. There's nowhere else for me to jump when x is negative 2, so I have a hole at negative 2. Whoops, I need a u, there we go, that I have to jump. Let's see, if I pick back up, numbers bigger than negative 2, I can keep moving along, but then, I hit another hole at 1. So I've got to jump that hole at 1, because there's nowhere else for me to go in my notation. And then anything greater than 1 is on the line that carries me the rest of the way out. So to infinity. Okie dokie smoky. Now let's look at the range. Up and down. Again, because of this arrow, I'm coming from the negative y values, and I'm doing fine. But then, when y is 0, I hit a hole. Negative infinity, comma, 0. So you gotta be careful how you look at this. Sometimes people try to go with the negative 2 again, but the range are y values. That's actually a value of 0 for that open dot there. Okay? So then any y value bigger than 0 is in this part, trucking along, but then bam! Over here, when y is 3, there's another hole to jump. So I'm going from 0 to 3, and then I gotta jump again, but then after I jump over that hole, I have positive y values, so to infinity again. Alright, I think I got one more. Yeah, look at this guy. Okay, so domain left to right. I don't have an arrow, so I know where I start. I start at the smallest x value of negative 5, but I use a parenthesis because it's an open dot, meaning don't include negative 5. So then anything bigger than negative 5, there's a place on the graph, there's a place on the graph at negative 1, but I'm supposed to jump from here to here. But hold up, What about all those x values? We totally just missed them. All the numbers between -1 and an x value of 0. Oh, we do a jump there. So I got to show that. I have to show that at -1, I include that value, but I have to jump to x value of 0 because this is a closed dot. I include it, and then bam, takes me out to infinity for the x's. So again, -5 I exclude. I had a place to go till -1 with a bracket. Then I had to do a jump because the x values of -1 to 0 were skipped. I picked back up at 0 and took it on out to infinity. So the range goes up and down. So because of this arrow shooting down here, I'm coming from the negative y's, coming up along that line, and I stop at -2. So for the y values, it's -infinity to -2. And then we gotta, oops, I needed a bracket there. Because -2 is too big of an eraser. Yikes. Because -2 had a closed dot. And so then the next part of the graph, whoa, it's all the way up here. This time, all of those y values are skipped. We have to jump all the way from a y value of -2 to a y value of 0 with a bracket. And then I'm traveling along, and then, after this point, you know, the graph, there's no more graph up there. So this guy caps off at a 2. And because that graph is on there, on the value of 2, my dashed line isn't very straight, it would be a bracket. Okay, so from -infinity to -2 takes care of this guy, and then the values of y of 0 to 2 take care of this little crescent moon, half circle kind of thing. Alright, I think that finishes this up. Oh, nope, I lied. I think that's the last one, this one. Okay, so the domain left to right, let's see. Obviously it looks like the smallest x value starts at -5 again, with a bracket because it's a closed dot. Good grief. And so as I move along, oh, here there are 2 places I could go, but that's okay. As long as there's a place for me to go. Here at 2, I end, but I could always jump down here and have a place to go all the way to 5. Okay, so for all of the x values between -5 and 5, whether it's the top part or the bottom part, there is a place for me to go between those 2 numbers. Sometimes I could double up, but that means it's a smooth -5 to 5, no jumps in our notation. We might jump on the graph, but we don't need to show a jump in our notation. Now the range up and down, let's see. Ooh, I forgot about this on this graph. We'll just call this a half here, because it looks like I kind of bottom out right here, and we'll call that -4.5. And we'll put a bracket since it's touching. And then, so I'm moving up, there's a place for me to go, Oh man, between 0 and -3. There's nowhere for me to go as I'm moving up. So I gotta show a jump in the notation for the range. -3 with a bracket is where I stop. -4.5 to -3. Then I have to do a jump, and I have to pick back up at y = 0, and I can travel up until about 3.5. So a y value of 0 picks me up at this upper part, and it goes all the way up to a y value of 3.5. So it's totally a visual thing. Kind of hard to, you just got to get used to them. Once you do, they're really easy. But now let's see. Oh, I'm gonna skip this one. It's okay. Oh, I have quite a few, but that's alright. I'm running out of time. That's it for me on this lesson video. You might want to check out this next video, finding domain and range of a rational expression. But like I said, that's it for this one. So keep learning, have fun, and I'll see you next time.